Welcome back, everybody. So today we are going to start talking about properties of logarithms. So these properties are unique to logarithms and only logarithms. And knowing these properties will help us solve potentially these logarithmic equations that we're eventually going to encounter in the next section. So the first thing we're going to talk about is the change of base form. Okay, this allows you to convert a logarithm with one base to either common logs or natural logs. So the question is, why in the heck would anyone even do this? Like, why would I even ever need to convert a log of, say, base 3 to common log, which is log base 10, or natural log, log base e? Well, for those of you using calculators, scientific calculators, not so much so with with graphing calculators, but with scientific calculators, they don't have a log base 3 key or a log base 5 key or a log base 7 key. The only keys, logarithm keys, that most calculators have are log base 10, which is common log, or log base e, or natural log. So you still want to find a way of calculating, for example, you want to be able to calculate what is, sorry, computer is backing up. You want to eventually be able to calculate, say, log base 3 of 7. Okay. And right now, there is no way to do that if you do not have the change of base form. So let's see what the change of base form says. The change of base form says that if I have a log base a of b, I can convert this in common log by doing the common log of b. Remember, common log is log base 10 over the common log of the base of the original log, which is a. And furthermore, instead of doing common log, I can also do this with natural log, log base, natural log of b over the natural log of the base, which is a. All right. So back to our original example, log base 3 of 7 can be estimated to be common log of 7 over the common log of 3, or you can also say the natural log of 7 over the natural log of 3. And you can enter these fractions into your calculator and get an estimate of log base 3 of 7. Now, changing a log from one base to another is not the only useful property of logs. And logs have actually multiple useful properties that those of you going into calculus or pre-calculus, and those of you even going to higher level math, we use quite a bit. And in fact, this is why we make a big deal about teaching everybody logs, because of the versatility that it enables. So the first property of logs is known as the product rule. And the product rule says the log of two numbers multiplied together equals, can be separated into log A plus log B. Okay. So the log of a product is equal to the log of the first factor plus the log of the second factor. Now, in this example, I did this with common log, but you can use any log of any base. So this property holds for natural log, Or I can use the same property, say with log base 7. So these properties are not dependent on the base that you use. These properties can be used with logs of any base. Okay. So the first one is the product rule. The second one is the quotient rule. Okay, the quotient rule. And the quotient rule says the log of a fraction is equal to the log of the numerator minus the log of the denominator. And again, this can be natural log of the numerator minus the natural log of the denominator, or the log of any base. Now, the last rule for logarithms, or the last property of logarithms, is known as the power rule. And the power rule says, and this is probably, I would say, the most useful characteristics of logarithms, that the log of an exponential expression, okay, log of a to the b power, is the same thing as b times the natural log of a, or b log. So what does this allow you to do? This allows you to, if you're taking the log of an exponential, this allows you to bring the exponent to the front and change the exponent to a product. Okay, so if you look at it, but before I go on, of course, you can do this with any log. So the natural log of a to b is the same thing as b times the natural log of a, and log base, say, 5 of a to the b is the same as b times the log base 5 of a. So let's look at the bigger picture here of what it does. It actually, logarithms take one operation and changes it to its lower level. So what do I mean by that? Well, let's look at the product rule, okay? You have two numbers multiplied together, you're taking the logarithm of that. So the log of two of a product of numbers. And you can dissolve that into an addition problem. It's the log of the first number plus the log of the second number. So you're changing a multiplication problem to an addition problem. Same thing with the quotient rule. The log of a over b, and remember a over b is a fraction, but moreover it's also a division problem. It's a divided by b. So the log of a over b can be rewritten as the log of a minus the log of b. So I'm changing a division problem into a subtraction problem. So the product rule allows me to change multiplication, the multiplication to addition. Quotient allows me to change division into subtraction. And lastly, the power rule is the log of a to the b power is equal to b, the exponent, times the log of a, the base. So I'm changing an exponential or power to a multiplication problem. So if you want to put a hierarchy, if you think about it as, if this is not really true, but if you can think of putting mathematical operations in hierarchy or order of complexity, the first one, the lowest level would be, say, addition and subtraction. They would be you would say, the easiest operations in math to learn. And it's the first operations that we teach you in kindergarten and first grade. The next level above would probably be multiplication and division. Okay, we teach you this around second and third grade. And then higher than that is like exponents or powers. So if you look at it, if you have an exponential operation with logarithms, it allows you to make that rewrite that exponential operation as one complexity lower as a multiplication problem. Okay, and likewise, you could take the log of a multiplication problem and write it as addition, or the log of a division problem and write it as subtraction. So these are characteristics that are unique to logarithms and makes them very useful. Okay? And I highly recommend that you memorize these properties. Okay? And this slide is in your lecture slides on Blackboard, and I highly recommend that you memorize these properties of logarithms: the product property, the quotient property, the power property, and the change of base property. Now, the next set of problems that we're going to be doing are called expansion and contraction of logarithms. So what do I mean by that? Well, expansion is taking multiplication, division, and exponents and rewriting them as multiple logarithm problems using addition, subtraction, or multiplication. So when if you're looking at these properties, expansion is taking a condensed logarithm or one logarithm and expanding it as using multiple logarithms. So expansion is going from left to right. And when you go from right to left, when you take multiple logarithms and shrink them down and condense them using these properties of logs into one logarithm, we call that contraction. So with these properties, going from left to right, known as expansion, going from right to left is known as contraction of logs. Now, before we move on, it is important to note this subtle point, that the product rule breaks up a multiplication into addition problems. The quotient rule takes a division problem and rewrites them as a subtraction problem. And the exponent and the power rule takes the exponent and rewrites it as a multiplication problem. But notice, we did the hierarchy, right? We did the easiest being the lowest level of mathematics being addition, subtraction, the next level being multiplication, division, and the next level being exponents. And since the lowest level is addition and subtraction, there is no property for addition and subtraction. So namely, a lot of students will do this. The log of a plus b is the same as the log of a plus the log of b. So they'll kind of like distribute the log. You can't do that, okay? You can't distribute. So this is not a true statement, okay? This is not true. You can't do this. Likewise, you cannot do the log of a minus b being the same as the log of a minus the log of b. This is also false. Okay? So you can't expand or contract addition and subtraction of logs like this, but you can expand a product, a quotient, and an exponent. And it is key to remember these things, that addition and subtraction cannot be expanded or contracted, but multiplication, division, and exponents can be. All right, so let's look at a couple of problems. So in this problem, I'm asked to write the following two examples, the natural log of 6 and the natural log of 2 over 227, in terms of the natural log of 2 and the natural log of 3. So let me also add to this. Let's say capital A is equal to the natural log of 2, and capital B is equal to the natural log of 3. Now, the problem is, I want you to rewrite the natural log of 6 using A and B. So how do we do that? Well, we first ask ourselves, how can I get 6 from 2 and 3? Well, 2 times 3 gives me 6. So the natural log of 6 can be written as the natural log of 2 times 3. Now, remember our product rule, okay? If I have a multiplication, I can separate it into an addition problem. So the natural log of 2 times 3 can be rewritten or expanded into the natural log of 2 plus the natural log of 3. Now, per my instructions, A was the natural log of 2 and B was the natural log of 3. So the natural log of 2 is A plus the natural log of 3 is B. So the natural log of 6 can be rewritten as A plus B. Now, we're going to do the same thing, but we're going to now do it with the natural log of 2 over 27. Okay. So the quotient rule says that 2 over 27 can be rewritten as the natural log of 2 minus the natural log of 27. Now, we do have a letter to replace the natural log of 2 with. We can replace it with A. However, we do not have a letter to replace the natural log of 27 with. So the question is, how can I rewrite 27 as a product or quotient of 2 and 3, or even an exponent of 2 or 3? So how do we do that? Well, 27 is equal to 3 times 3 times 3, or another way of writing it is 3 cubed. Okay. So we can rewrite the natural log of 27 as the natural log of 3 cubed. Okay. So again, my main thing was, okay, I can replace the natural log of 2 with a letter, but I cannot replace it with replace the natural log of 27. However, how can I take 27 and get 27 from, like, say, the product of 2 and or 3? Well, 2 is not a factor of 27, but 3 is. 3 times 3 times 3, okay? So that means 27 is equivalent to 3 cubed. So that's all I did, is I replaced 27 with 3 cubed. Now, the power rule says that if I have a number raised to an exponent, I can bring that exponent to the front of a logarithm. So I can rewrite this as the natural log of 2 minus 3 times the natural log of 3. Okay, that's what the power rule says, that the natural log of 3 cubed is the same as 3 times the natural log of 3. Now, natural log of 2, I can replace that with A per my instructions. And natural log of 3, I can replace that with B. So I can rewrite the natural log of 2 over 27 using A and B and write it as A minus 3B. You've got problems like this on your study guide and on your practice problems, so I highly recommend that you practice doing these. And actually it becomes kind of a game, so it becomes fun after a while. And I understand fun is a relative thing. What's fun for some person might be a nightmare and hell on earth for another, but what can I say? I'm a freak. So, okay, let's look at some more problem types involving expansion and contraction. Okay, in this problem, it says to expand the logarithmic expressions. So I want, for A, I want to expand log base 4 of 5 x cubed y. Okay. So when I say expansion, that means I do not want anything within the logarithm being multiplied or raised to an exponent. So I want to get rid of all my multiplication if possible, and I want to get rid of all my exponents if possible. All right? Now, the first thing we're going to say is, well, log base 4 of 5x cubed y, the product rule says I can rewrite this as an addition problem. So this is the same as log base 4 of 5 plus log base 4 of x cubed plus the log base 4 of y. Now, is it fully expanded yet? Well, remember, my goal is that I do not want any multiplication or exponents within the logarithm. So here, I don't have any multiplication or exponents. Here, I don't have any multiplication or exponents. But here, I have an exponent. So I have to do something to get rid of that exponent. Well, remember the power rule. The power rule says that I can rewrite log base 4 of x cubed as 3 times log base 4 of x. And I said, remember I said that this is probably one of the most useful characteristics of logarithms, that it allows me to bring my exponent to the front of the logarithm. So, rewriting this, log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. And I know it's fully expanded because there's nothing being multiplied within the logarithm, and there's no exponents within the logarithm. Right, now let's look at the next example. The next example says I want to fully expand the natural log of the square root of 3x minus 5 over 7. Now, what I would recommend is that you pause the video and try to do it yourself, and then come back to see the solution, or it worked out. So let's go for it. So the first thing I'm going to do is rewrite my fraction using the quotient rule. And the quotient rule says that I can rewrite this with subtraction, that it is the natural log of the numerator minus the natural log of the denominator. So this is the natural log of the square root of 3x minus 5 minus the natural log of 7. Okay. Now, am I done? Is it fully expanded? Well, I know for this part of the expansion, I'm done. There's nothing I can really do. There's nothing else within the logarithm being multiplied or raised to an exponent or divided, so there's nothing to expand. Okay. However, there is something I can do with this. Because remember, the square root of a number is the same thing as that number raised to the 1/2 power. Okay, so remember the relationship between your roots and your rational exponents. So just to remind you, as a rule, the nth root of a is the same as a to the 1 over n power, okay, where n is the index of your radical. So remember, if the radical doesn't have an index, the understood index is 2, or square root. So what I would do in this problem is rewrite the square root of 3x minus 5 as 3x minus 5 to the 1/2 power. Now, why did I do this? Well, now that I have an exponent, what can I do? What does the the power rules say? It says that I can bring the exponent to the front. Okay. Now, the next question is there anything else for me to expand? So some of you will say, well, wait a minute, I got a 3x here. That's 3 times x. But there's a problem, okay? I can't distribute the natural log. So in order for me to be able to expand the natural log of 3x minus 5, or separate the 3 and the x, I have to first rewrite this as the natural log of 3x minus the natural log of 5. But remember from our previous discussions, we can't do that, okay? We can't do that. So this is not a true statement. So we can't separate this, so we can't further expand anymore. So I know what some of y'all will say is, well, wait a minute, can I rewrite the natural log of 3x minus 5 as the natural log of 3 plus the natural log of x minus 5? Okay. Well, no, you can't do that, because remember, what does the natural log of 3 plus the natural log of 3 of x minus 5 mean? Well, that means it's the natural log of 3 times x minus 5, which if we distribute is the natural log of 3x minus 10, which is not the same as my expression right here. So we're in a quandary. What do we do? Well, the answer is we don't do anything. It is fully expanded. There's nothing more that we can do that would not change the actual expression 3x minus 5. So this logarithm is fully expanded. Again, there's going to be problem types like this in both the study guide and the bonus homework, not the bonus homework, but the practice homework problems. I highly recommend that you practice these. It is one of these concepts that initially the first go is going to be kind of difficult because you're going to have to go back and refer back to the rules. But the more you keep doing this, you'll remember the different rules, the different properties, whether it is the product rule, the quotient rule, or the power rule, and then you'll be able to do it without thinking twice. Now let's look at problem types that go in reverse. So in these problems, I was asked to expand. And in the next problems, I'm going to be asked to contract. So take multiple logarithms and rewrite them, if possible, as one logarithm. Okay, so in these problems, as I said, we're going to condense or rewrite all of these multiple logarithms as one log. So let's start off with A. 1/2 log of x plus 3 common log of x plus 1. So when you're condensing logarithms, you want to work from the outside in. So what do I mean by that? Well, you want to get rid of any exponent, anything being multiplied to the logarithm first by using the power rule. And then you want to do the product rule by condensing any addition to multiplication. And then lastly, you want to do the quotient rule by condensing any subtraction problems as a fraction. So, A, the power rule says I can rewrite 1/2 log x as log x to the 1/2 power. Now, you can leave it like this, or you can rewrite this as the log of the square root of x. It doesn't matter to me which way you do it. Just know that both manners are fine by me. Okay, now 3 log x plus 1. The power rule says I can rewrite this as the log of x plus 1 cubed. Okay. So I got rid of any numbers being multiplied to the front of the log by rewriting them as exponents. So now my problem looks like log is the square root of x plus the log x plus 1 cubed. Now, we still have two logarithms in our expression, so we still have to do more condensing to rewrite this as one log. So how do we do that? Well, remember the product rule. The product rule says I can write the addition of two logs as one log. So this is the log of the square root of x times x plus 1 cubed. Now, you can write this like this, or you can use a rational exponent. So either one of these answers would be acceptable on any type of test or a quiz. And this is now two logarithms written as one log. And this is fully condensed or contracted. All right? Now B. B says 2 times the natural log of x plus 2 minus the natural log of x. So you remember the way I told you would be the easiest way to do it. Now, it's not the only way to do it, but in my practice, this methodology is the easiest way for most students. First, you want to use the power rule. Then you want to use the product rule when possible. Then you want to use the quotient rule when possible. Now, one thing is to be said that I forgot to say earlier. You can only condense when the logarithms have the same base. So, for example, here, I could condense these because they're both common logs, log base 10. I can condense these because they're both natural logs, log base e. Okay? But say, for example, I had, say, the natural log of x plus the common log of y. I cannot rewrite this as, say, the natural log of xy. And the reason is because the logs have different bases. So, for example, in this is log base e, and this is log base 10. So contraction can only occur when the logs have the same base. So let's go back to this problem. So remember, the first thing I'm going to do is the power rule. So I can rewrite this expression by taking the number being multiplied in front of the log and write it as an exponent. So I'm going to take the 2 and make it the exponent of x plus 2. So this is the natural log of x plus 2 squared minus the natural log of x. Now, the next thing, product rule. Well, I can only use the product rule if I have logs of the same base being added to one another. But I don't have that. I don't have an addition problem here. So there is no opportunity for me to utilize the product rule. So the last rule is the quotient rule, used when I have logs of the same base subtracted from one another. Well, I do have that here. Okay, I have the natural log of x plus 2 squared minus the natural log of x. And the quotient rule says that I can rewrite this as the natural log of x plus 2 squared over x. Okay. And that would be my final answer. Okay. Now, there's nothing else to contract because I have condensed the entire expression into one logarithm. I got rid of all my separate logs and wrote them as one. Okay. And that's about it right now for this problem. There's nothing more that I can feasibly do with this problem anymore. So it's fully contracted. So the question is, why would anyone want to do this? Well, you're going to see in the next section that we're going to start solving equations. We're going to be solving exponential equations that may or may not use logarithms. Well, when we have an equation with multiple logarithms, before we can invert it, we have to condense it into one logarithm. So this is a skill that we're going to be using quite rapidly, quite soon into the next section. So anyways, let's worry about this section first and finish up with the last problem. 1/3 times, in brackets, log base 2 of x plus log base 2 of x plus 1, close brackets. Now, what do? Well, we are at a little bit of an impasse because we have never ever encountered something where we have 1/3 times two logarithmic expressions. So how do we do this? Well, there's two ways you can do this, and I'm going to show you both ways. The first way is to sort of fully expand what this thing means. Okay. What is it? What am I implying when I say 1/3 times in brackets all of this? Well, I mean that's 1/3 times log base 2 of x plus 1/3 times log base 2 of x plus 1. So I can distribute the 1/3. Okay, remember when you have a number in front of a parentheses, you distribute whatever's outside the parentheses, in this case brackets, to everything inside the parentheses. That's the distributive property. Okay, and that's what I'm going to do. Because by doing that, now I have a number in front of a logarithm, and now I know how to deal with that because the power rule tells me. So the first way I would do this is say, okay, well, I would distribute and get, and I'm going to write this on this side. So this is 1/3 times the log base 2 of x plus 1/3 times the log base 2 of x plus 1. Okay. Now, how do I deal with a number in the front of a logarithm? Well, remember the power rule. I can rewrite this as log base 2 of x to the 1/3 plus log base 2 of x plus 1 to the 1/3. Now, you're more than welcome to rewrite, say, for example, log base 2 of x plus 1 to the 1/3 using radical signs, okay? And remember, what does a to the 1/3 power mean? It is the cube root of a. So you can rewrite this as log base 2 of the cube root of x plus 1. And that's up to you, or you can leave it like this. It doesn't matter. Okay. And I'm just going to, for argument's sake, I'm just going to leave it like this. Now, what do I do next? Well, I don't have any more numbers in front of the logarithm, so I can't use the power rule anymore. So I go to my next one, which is my product rule. And product rule says if I have any addition, I can write them as a product. And I do. So this is the same as log base 2 of x to the 1/3 times x plus 1 to the 1/3. Now, the reason logarithms give a lot of people a challenge is because it requires your full knowledge of all of the previous math concepts that you've learned. So remember properties of exponents. If you have two numbers multiplied together raised to an exponent, the exponent rule says that I can distribute that exponent to each number being multiplied. That's the power rule. That's the power of a product rule of exponents. So I can rewrite log base 2 of x to the 1/3, x plus 1 to the 1/3, since both of these numbers are being raised to the 1/3 power. I can rewrite this as log base 2 of x times x plus 1 to the 1/3. But I would much rather you leave it like this. I'm just showing you that this is an option. And you're going to see why that is an option in a second. So there's no more logarithms to condense, so that's my answer. Now, let's look at the alternative method, method 2. Now, in method 2, remember I said initially that you want to do the power rule, then the product rule, then the quotient rule. And I said for 95% of the time, that would be the easiest order of steps that you can do. But I said 95% of the time. That does mean 5% of the time you may want to do another step before you do, say, the power rule. Okay, so you may want to do sometimes the product rule before you do the power rule. It does not matter which order you do the steps in. Okay, you can do the power rule of the product rule first, then the power rule, then the quotient rule, or you can do the quotient rule first, then the product rule, then the power rule. It doesn't matter which order you do it in. It's not order dependent. So I can, instead of distributing 1/3 like I did in this method 1, I can start off by working within the bracket and say, okay, well, I can condense this entire these two logarithms into one using the product rule. The log base 2 of x plus the log base 2 of x plus 1 can be rewritten as 1/3 times log base 2 of x times x plus 1. Okay. Now, what do? Am I done? No, you're not done because you got a number in front of the logarithm. So what do we do with the number in front? Well, the power rule says that I make that an exponent. Now, why did I use brackets? Well, because 1/3 is the exponent for this entire expression. 1/3 is the exponent for this entire expression. So that's why I have to put this in brackets before I add my exponent. Because if I rewrote it like this, remember my rule of exponents. The number or variable directly in front of the exponent, or whatever's in, or the stuff in parentheses directly in front of the exponent, is the base of that exponent. So if I rewrote the expression like this, that means 1/3 is only the exponent for x plus 1. But that's not what this is implying. This is saying 1/3 is the exponent for not just x plus 1, but x and x plus 1. So to indicate that, I have to put this in brackets. And that's the reason why I did a bracket around x and x plus 1 to indicate that 1/3 is the exponent for x and 1/3 is the exponent for x plus 1. Now remember, you've seen this in the first step. This is the step right here, okay? And remember what the power of a product says, that if I have multiple things being multiplied together raised to the same exponent, I can distribute that exponent to everything being multiplied. So I can rewrite this as log base 2 of x to the 1/3, x plus 1 to the 1/3. And this is why I wanted you to write the answer in this form and not in this form. Not that this is wrong, this is totally right, but this is more, you could say, I wouldn't say concise, but this is just more appealing, if you will. So whichever method you found easy, it's fine by me. You can distribute the 1/3 and then use the power rule and then the product rule, or you can first use the product rule and then use your properties of exponents, which you definitely still need to know all those properties of exponents. So in order, before you even begin to start learning the properties of logarithms, you need to know the properties of the exponents. Okay, so the product rule of exponents, the power rule of exponents, the power of a product, the power of a quotient, all of those things, zero rule, etc. Okay, let's look at one more problem. Okay, the last problem type that you may encounter from this section is something like this. Find the exact value of log base 5 of the cube root of x, cube root of 5 without using a calculator. And this is what we had to do before, back in the day, before calculators became as sophisticated as they are with graphing functions and whatnot. So how do I do this? Well, we're going to use our properties of logarithms. So log base 5 of the cube root of 5. So remember in our previous discussion about exponents and radicals and roots and rational exponents. How can I rewrite the cube root of 5 using rational or fraction exponents? Yeah, I can rewrite cube root of 5 as 5 to the 1/3 power. Okay. So log base 5 of the cube root of 5 is the same as log base 5 of 5 to the 1/3 power. So what do I do with an exponent inside of a logarithm when I'm not contracting it? What does logarithms allow me to do with exponents? Yeah, you can bring it to the front. So this is the same as 1/3 times log base 5 of 5. Well, what is log base 5 of 5? Remember from our previous lecture, this is one of the identities of a log. So the log base a of a is 1. Remember how to do these? 5 to what power gives me 5? 5 to what power gives me 5? Well, 5 raised to the first power is 5. So log base 5 of 5 is just 1. And 1/3 times 1 is just 1/3. So the log base 5 of the cube root of 5 is basically 1/3. Now, before I let you go, I want to say one more thing. Let's look at the difference between, say, common log of 2 cubed versus the common log of 2, all of it cubed. The common log of 2 cubed can be rewritten using the power rule as 3 times the common log of 2. Because I'm taking the log of an exponential, okay, 3 cubed. The exponent here, 3, only applies to the 2, okay? So 2 is the only thing being cubed because the 3, the base of the exponent is 2. However, here, what is the base of this exponent? The base of this exponent is log 2. So this is the same as log 2 times log 2 times log 2, whatever that is, okay? So this is a place where a lot of students make mistakes. The property of the power rule says the natural log or the log of a to the b power. So you take the log of an exponential is the same as b times the natural log of a. Because this exponent, the base of this exponent b is the variable a. However, what a lot of students will do is say, oh, okay, well, the natural log of a to the b power like this, written like this, is the same as b times the natural log of a. That is not true, okay? The difference is, in the previous example, b is the exponent, and the base of that exponent is a. In this example, for the exponent b, the whole natural log of a is the base, okay? So you can't do the power rule when the problem is written like this, where the base of the exponent is the entire natural log or the log. So this is where we're going to end the lecture. I highly recommend that you go back to your study guide and to your practice problems and practice expansion, contraction, and conversion of logs to other logs, like problems like this. Okay, so do your expansion and contraction problems and make sure you practice problems like this where you're rewriting one logarithm as an operation involving 2 other logs. Because this is where this problem type is quite confusing for many students. So make sure you get a good practice amount with that. And make sure to ask questions if you can't do it during one of our video conferencing sessions. And again, remember your 3 properties, the product rule, the quotient rule, the power rule, and remember the change of base as well. And remember what it allows us to do, the purpose of why logarithms are so important in mathematics, because it takes a higher operation and makes it into 1 step lower, making an exponent into a multiplication, or making multiplication into, and division into addition or subtraction, respectively. So if you have any questions, write it down. Make sure you ask me or during our video conference session, or you're more than welcome to text and email me, and I will see you next time. Have a good night.